You know, every once in a while, a tech announcement comes along that does more than just launch a new gadget. It completely shifts the conversation for the entire industry. Well, today, we're breaking down one of those moments. Let's get right into it. We're talking about the brand new system from OpenAI, GPT-5.3 Codex. So I want you to picture this. The date is February 5th, 2026. Yeah, a little ways into the future. But that's the day OpenAI decides to unveil what could seriously be a pivotal new tool in the world of AI, and specifically coding. And they are not pulling any punches with this one. Let's just start with OpenAI's own words right from their announcement. They're calling this the most capable agentic coding model to date. That is a huge claim. So what does that actually mean? Let's unpack it. So what is this thing, really? Well, OpenAI has a pretty interesting way of framing it. They want you to think of it as an AI colleague. And that's not just marketing speak. This isn't a tool that just answers a question and then stops. Oh no. It's designed to be an active partner, working alongside you on really complex projects. The key word here, the one you really need to remember, is agentic. And trust me, this is a game changer. An agentic AI doesn't just write a quick snippet of code for you. It can take a really broad goal, go out and research the problem, figure out what tools it needs, and then actually execute a complex, multi-step plan to get it done. It has agency. It thinks for itself. So how does it work? It basically breaks down into 3 big stages. First, it does the research, right? It gathers all the information it needs. Then, it moves on to using tools. This could be anything from interacting with APIs, running code, or accessing databases. And finally, it pulls everything together for what they call complex execution. Seriously, think of it less like a calculator and more like a super intelligent project manager that can also do all the work. Okay, but with this kind of power, you guessed it, it comes with a whole new world of questions and, frankly, risks. And to their credit, OpenAI is being super transparent about how they're looking at these risks. They're using a framework they call capability thresholds. Now, this table from their own system card is absolutely crucial. Take a look. For biology, it's rated high, which is pretty consistent with their other big models. For AI self-improvement, it's not high, and that's a big sigh of relief for a lot of people. But then look at that last row. Cybersecurity is rated high, but with a really important note, precautionary. This is the very first time OpenAI has ever launched a model with that kind of warning label. And that cybersecurity rating, that is the real story here. So why is it such a massive deal? Well, think about it. An AI that can autonomously research, use tools, and execute complex code could be an unbelievably powerful weapon for finding and exploiting security holes. We could be looking at the start of a whole new kind of arms race in cyberspace. This quote really gets to the heart of the matter. OpenAI is basically telling us, look, our tests don't prove this thing can cause catastrophic cyber harm, but we can't prove that it can't either. And that deep uncertainty is forcing them to treat it as if it's already a high-risk tool, just in case. Which, of course, brings us to the classic dilemma of any powerful new tech. It can be used for amazing good and for terrible evil. So what's the game plan here? How do you manage a tool that could be used by the very people building our digital world and the people trying to tear it all down? I mean, it is the definition of a double-edged sword. On one hand, you can imagine cyber defenders using this AI to find and patch security flaws at a speed we can't even comprehend. The potential there is just immense. But on the other hand, the bad guys, the threat actors, could use that exact same power to automate the discovery of new ways to attack us. So what's the plan? OpenAI is laying out a 3-part strategy. First, build what they call a layered safety stack with really strong security measures. Second, they're promising to actively hunt down and disrupt anyone trying to misuse the tool. And third, and this might be the most important part, they plan to empower the cyber defenders, making sure they have access to the exact same powerful tools. The idea is to tip the scales in favor of the good guys, which could set a huge precedent for how we roll out these kinds of technologies in the future. So when you boil it all down, the launch of GPT 5.3 Codex really comes down to this one fundamental tension. We are looking at a technology with just an immense promise to revolutionize how we defend ourselves online. But at the exact same time, it introduces a level of risk that is truly unprecedented. And that leaves us all with this one final critical question to chew on. When a single tool makes both the person building the lock and the person breaking the lock exponentially more powerful, who actually wins in the end? That's the question not just for OpenAI, but for all of us. And we're all going to be watching very closely to see how it unfolds.
So, get this. On February 5th, 2026, Anthropic just dropped a major update to its AI lineup. We're talking about a brand new flagship model called Claude Opus 4.6. So in this explainer, we're going to break it all down for you. What's new, what's so powerful, and what it really means for all of us.
And right out of the gate, the claims they're making, they are huge. We're not just talking about a little tweak here. Anthropic is positioning Opus 4.6 as the new state-of-the-art, the new top dog, and it's already setting some crazy records. But you know, with any big announcement like this, you gotta be a little skeptical, right? The hype is always a mile high, but does the performance actually live up to it? So, that's the big question we're digging into today. Is this thing the real deal? Is it a genuine leap forward? All right, to answer that, we've got to look at the numbers. Let's get into the hard evidence and see how Opus 4.6 really stacks up against the competition where it counts. Okay, look at this. This is where things get really interesting. We're talking about sheer dominance here. This chart uses an LO rating system, like they use for chess players, to measure how well these models do complex work in things like finance and law. And that massive bar for Opus 4.6, that's a 144-point lead over its biggest rival. A lead that big means it's expected to win something like 70% of the time. I mean, that's not just winning a race. That's like showing up in a supercar when everyone else is on a bicycle. It's a whole different league. So this next number tackles one of the biggest, most annoying problems in AI, context. That 76% you see is its score on a brutal needle-in-a-haystack test. They basically hide one tiny fact in a document the size of a novel and ask the AI to find it. The last model, it only scored 18.5%. This new one, 76%. That is a gigantic leap. It basically means that problem where the AI forgets what you were talking about 5 minutes ago, yeah, that's pretty much on its way to being solved. And the key takeaway here is that this thing isn't a one-trick pony. Not at all. When you look at the whole scoreboard, Opus 4.6 is at the top of the charts for agentic coding, for complex reasoning, and even for those really tricky web search tasks. It's a massive upgrade across the board. Okay, so we've seen the what. Pretty impressive, right? But now let's pop the hood and look at the how. What's the secret sauce here? What are the technical upgrades that are making all this possible? All right, the big buzzword you're going to hear a lot is agentic skills. This is the heart of the whole upgrade. Think of it this way. We're moving from a simple tool that just answers questions to a true collaborator. You can give it a big, complicated goal, and it can figure out the steps, do the work, and even change its plan on the fly, all without you having to hold its hand. Let's break that down with a real-world example. Say you tell it to migrate a giant software code base. An AI with these agentic skills won't just blindly start typing code. No, first it breaks down the request. Then it plans out all the little subtasks, and it can even do some of them at the same time. But here's the kicker. It then reviews its own work, finds its own mistakes, and fixes them. It's basically thinking and working the way a senior engineer would. And to back up this new agentic brain, you've got a whole suite of powerful new features. There's that massive 1 million token context window we talked about. But there's also something called context compaction, which helps it summarize long chats to stay on track. Developers are also getting new controls to dial the model's thinking effort up or down. And on top of all that, you got major upgrades for using it in everyday tools like Excel and PowerPoint. Benchmarks and tech specs are one thing. But what does all this power actually feel like to use in the real world? Well, let's hear from some of the early partners who've been kicking the tires on this thing. Wow, this quote from SentinelOne really says it all. Like a senior engineer, that is a heavy statement. It's not just a coding helper anymore. It's acting like a strategic partner that can plan, adapt, and get these incredibly complex jobs done way, way faster. And hey, this isn't just for the super technical crowd. This quote from Notion shows the other side of it. For everyday work, for creative projects, the feeling is the same. It's moving from being just another tool to being, and I love this phrase, a capable collaborator that you can actually trust to get things done. And to really hammer the point home, check this out from Harvey, a company that builds AI for lawyers. Nailing a 90% score on a benchmark for complex legal reasoning, that just goes to show you the model's intelligence isn't a mile wide and an inch deep. No, it's got serious depth, performing at an expert level in these super specialized fields. So okay, we've established it's smarter, it's way more capable. But that always brings up a few really important questions, right? What about safety? What's it going to cost me? And how do I get my hands on it? Let's cover that now. Look, whenever an AI gets this powerful, the first question on everyone's mind is safety, and rightfully so. The good news is Anthropic says these huge intelligence gains don't come at the cost of safety. It's just as safe as before, but it actually has the lowest rate of over-refusals. You know that annoying thing where an AI refuses to answer a perfectly normal, safe question? Yeah, it does that less. That's a huge quality of life improvement right there. And here's maybe the best part of all. You can use it right now. It's already on the Claude website, available through the API, and our major cloud platforms. And get this, and this is a big deal for getting people to actually use it, they didn't raise the price. It costs exactly the same as the old model.
So let's just put a bow on this. You've got a massive leap in AI intelligence that's available today. It costs you the exact same amount of money, and it's safer than ever. I mean, that's pretty much the whole package right there.
At the end of the day, a tool this powerful is really about what we do with it. This kind of AI, one that acts more like a collaborator than a simple tool, it completely moves the goalposts for what we thought was possible. It's not just about asking better questions anymore. It's about setting more ambitious goals. So it really leaves us with one huge, exciting question. What are we going to build with it?
All right, if you're a developer and you've ever had to generate synthetic data, you know the pain, right? The endless YAML files, the command line guesswork, it can be a real headache. But what if you could turn all that code-heavy chaos into a clean, visual, and totally transparent graph? Well, today we're diving into a tool that promises to do just that. It's called SyGRA Studio. So let's just set the stage here. Think about the way we normally do this. You're deep in some config files, you're staring at a terminal, you're running commands, and just kind of hoping that all the different pieces are wired up correctly. It really is a black box. You have all this incredible power at your fingertips, but the process itself, it can be so opaque and, let's be honest, super frustrating. And this slide just nails that contrast. On the left, that's the world many of us live in, juggling all those YAML files, working at a disconnected terminal. It's a mess. But on the right, that's the promise of SyGRA Studio, a clean, visual canvas, live previews so you see what you're doing, and everything managed from one single pane of glass. It's a totally different philosophy.
So how do we get from that chaos on the left to that clarity on the right? Well, let's meet the solution. This is SyGRA Studio, and it's an interactive environment that's really designed to make us rethink how we build these data pipelines from the ground up.
You know, I think the most important phrase here is visual craft. This isn't about hiding the complexity or dumbing it down, no way. It's about making that complexity manageable and intuitive. The whole goal is to make the entire process transparent, so you always know exactly what's happening under the hood. So how does it do it? Well, it's all about bringing every critical piece of the workflow into one spot. You get these guided forms to build your logic, so no more guesswork. You connect your data sources, and boom, you get instant previews. You can debug, you can monitor everything, we're talking costs, latency, the whole shebang, all from this one visual canvas. Every single feature here is designed to solve a very common, very real frustration. Okay, so that's the high-level pitch. Sounds great, right? But what does it actually look like to use it? Let's walk through a super simple workflow to see just how fast you can get from a basic idea to a real result. And it really just comes down to three main steps.
Yep, it's a simple three-part process. First, you hook up your data. Second, you build out your logic on the visual canvas. And third, you hit run and review the results. So let's break down what each of those steps actually looks like inside the studio.
First up, data. It's simple. You just point Studio to your Hugging Face dataset, maybe a local file. But here's the magic. Once you click Preview, the column names from your data, they automatically become variables that you can use everywhere else in your flow. Think about that. No more manual wiring, no more typos in your variable names. It just works. Okay, now for step 2, building the actual flow. So you've got those variables ready to go. You literally just drag components, like an LLM node, right onto the canvas. And when you start writing your prompt, those data variables we just talked about, they're auto-suggested for you. Then you can just chain the output of one node directly into the input of the next. It's all visual, it's all connected. And finally, step 3, we run it. You click Run, but you don't just get a file at the end and cross your fingers. No, you get to watch the entire pipeline execute, live. You see exactly which node is running, and you get real-time stats on your token usage, your cost, and your latency. That observability isn't some extra feature. It's baked right into the process from the start.
Okay, so a simple linear flow is one thing. That's pretty cool. But let's be real. Real-world data pipelines are messy. They've got loops, they've got conditionals, all sorts of complex logic. So the big question is, can a visual tool really handle that kind of complexity?
That's the million-dollar question, right? Can it handle the tricky stuff? Let's put it to the test. To answer that, we're going to look at a much more advanced example. This is the Glaive Code Assistant workflow. And this is the perfect test case because it is not linear. It generates an answer, then it has another LLM critique that answer, and then it loops through that whole revision process until the output is good enough. This is exactly the kind of conditional looping that's a nightmare to manage in code. And this is how Studio visualizes that complexity. You can literally see the conditional edge that creates the revision loop. You can tweak parameters like temperature or batch size on the fly without ever touching a config file. And as it's running, you can watch the nodes light up and actually inspect the intermediate critiques as they happen. It takes a highly complex process and makes it completely transparent.
So, what's the big takeaway here? What does all this add up to? Well, the ultimate payoff of shifting to this visual approach is one huge thing: full transparency into your entire data generation process.
So what's the real advantage for you? It means you build with confidence because you can see everything you're doing. Debugging is suddenly simple because you have that full observability. You can monitor your costs in real time, and here's a killer feature. You're not locked into the UI. Under the hood, Studio is generating standard SyGRA config files so you get the best of both worlds: easy visual development and portable code-based artifacts you can use anywhere.
You know, this quote from the team behind SyGRA really just says it all, doesn't it? Configure once, build with confidence, run with full observability, generate the data without ever leaving the canvas. It's about creating this seamless, integrated, and totally transparent experience from start to finish. And that really leaves us with one final exciting question. By making these powerful workflows so much more intuitive, we're lowering the barrier for everyone to create really high-quality data. So when data generation stops being a battle with code and actually becomes a visual craft, what amazing new things will you be able to create?
You ever see this? An AI model gets a perfect straight A report card on some benchmark test, but then you try to use it for a simple real-world task, and it completely faceplants. It's kind of like a student with a perfect GPA who, can't figure out how to do their own laundry. Well, this is AI's report card problem, and today we're going to figure out exactly why our smartest on paper models are flunking real life. So what is the deal here? Why is a model that looks absolutely flawless on paper tripping over itself when it faces a genuinely useful task? The answer, and this is the key, isn't that the AI is dumb. It's that the entire system we're using to grade it is, well, it's broken. I mean, just look at the contrast. On the one side, you've got these incredible test scores. Models are crushing huge language tests like MLLU, scoring over 90%. They're acing math benchmarks like GSM 8K. But then, on the other side, you hear story after story about how these same genius models can't reliably do something like browse the web or write code that you'd actually use. The star student just can't handle a real job, and that disconnect is massive. So yeah, the system we use for grading these things is fundamentally flawed. And it's not just one little thing. There are two really critical gaps that are causing all this confusion. So let's break them down. Okay, first up is what we can call the benchmark reality gap. Think of it like this. Our academic tests are measuring a model's ability to answer trivia questions. But what we really need is for that model to, say, write a novel. Acing a multiple choice test is one skill, for sure. But navigating the messy, unpredictable chaos of a real software project, that's a completely different ballgame. The benchmarks just aren't testing for the skills that actually matter to us. And the second problem is, honestly, it's just as frustrating. It's the reporting gap. So you go to look up a model's score on a really important benchmark. You'll see one number in the official research paper, a different number on the model card, and maybe a third totally different number on some evaluation platform. So which one is right? It's literally impossible to know who to trust. And the results of that reporting gap? It's just chaos. Without one single reliable place to check the facts, a single source of truth, the whole community is just flying blind. I mean, how are we supposed to compare models or even track progress if we can't agree on the basic scores? But what if the fix isn't just another shiny, new, centralized leaderboard? what if the real solution is the complete opposite of that? Well, that's the big idea behind a new project from Hugging Face called Community Evals. It's their attempt to fix this whole mess by decentralizing evaluation and putting the power back where it belongs, in the hands of the community. So, what are community evals? It's actually a pretty radical idea. It's a system where literally anyone, a researcher, a developer, even just a curious hobbyist, can submit their own evaluation results for any model out there. The goal is to create this open, shared, and totally verifiable public record of how a model actually performs over time. Okay, that's a big picture. But how does it actually work in practice? Well, the whole system is built on 3 core pieces that all work together on the Hugging Face hub. Let's dig into how they all fit together. So first, the benchmarks themselves get a serious upgrade. Every dataset page can now have its own leaderboard, and it automatically pulls in every single submitted score from across the hub. But the most important part is this. It defines a single, reproducible way to run the test using a simple configuration file. This means everyone is finally playing by the exact same rules. No more guessing games. Second, the models themselves become the home for their own report cards. The evaluation results live right there in the model's own repository, and they show up on the official model card. And get this, it shows the author's original scores right next to the scores submitted by the community. Everything is right there, out in the open for everyone to see. And finally, there's us, the community. Anybody can submit their results using a standard process, a pull request. You can link to your sources, like a paper or your code logs. You can openly discuss the scores. And because it's all built on Git, every single submission creates a permanent, transparent, and public record. It's all there in the history. So why does all this matter so much? It's really about taking this mysterious black box process that nobody really understands and turning it into a completely visible, open playing field. A field where everyone can participate, and more importantly, where everyone can check the results for themselves. And when you put it side by side with the old way, wow, the difference is stark. The old black box leaderboards were opaque, centralized, and honestly a nightmare to reproduce. But with community evals, it's open, it's verifiable through Git, and it aggregates everything in one central place. And since reproducibility is literally built into the system, you can actually trust the results you're seeing. Now, let's be real for a second. This new system isn't a magic wand. It's not going to suddenly fix that gap between benchmarks and reality we talked about, and it's not going to stop some people from secretly training their models on the test questions. Those are much deeper, separate problems we still have to solve. But here's the thing. Here's what it does do. It makes the entire game of evaluation visible to everyone. For the very first time, we can all see exactly what is being tested, how it's being tested, when it was tested, and who did the testing. And that level of transparency, that is the real revolution here. This new system, it's not just a tool, you know? It's really an invitation. It's a chance for the entire AI community to take back control of evaluation and to build a more honest, more transparent future together. And the best part is you can be a part of it. You can literally get started today. If you've run an evaluation on a model, go publish your results. They're just simple text files. You can also just go explore the new leaderboards that are already live on some of the biggest benchmark datasets. And hey, if you've created a better, more real-world benchmark, you can register it and help build this new ecosystem from the ground up. Which leaves us with this one really fascinating question. We're shifting from a closed, top-down system to an open, community-driven one. So when you give the power of evaluation to everyone, when you open the floodgates, what truths are we going to uncover about the models we're all so busy building? And what new, unexpected challenges will pop up? The answers to that, well, they could reshape the entire future of AI.